This video is the second part on our applications of parabolas. So in the previous examples we've seen, you actually were given the equation. In this next example, you're not given the equation, so you're going to have to come up with it on your own. So coming up with this on your own, really means that you should be thinking about the problem, using let statements, and then writing your equation. So in this example here, it says you have 400 feet of fence to enclose a rectangular plot of land along a river. If you don't need to fence along the river, what is the maximum area you can enclose? So what you're really looking at is, here's a river, let's say, and you need to fence in a rectangular plot of land, so like that. So you don't need any fence on the side where the river is. All right, so you only need fence, here, here, and here. So we're trying to find the maximum area. So that's important to remember in the end of this. So we're looking for a maximum. But in order to figure out, the maximum area we can enclose, we really need to find the dimensions. And they don't really say that explicitly in the problem, but you need to really figure out, what this length has to be on each side and what this length has to be. So I'm going to start by saying let x equal the width, which I'm calling with this x here. So this length is going to be x, this width I should say is x, and this is also going to be x because it's a rectangle, so the opposite side should be the same. It's easiest to start by making the sides that you have two of your first let statement. Well, how would I talk about the length here? Now the key to this is that they tell you there's 400 feet of fence total. So if there's 400 feet of fence total here, and I've used x here and x here, how much is left for this part? Well, what's left here is 400 minus what you already used on these pieces, right? 400 was the total fence. How much did I use here and how much did I use here? Well, 400 minus x is 400 minus 2x. So we're going to let 400 minus 2x equal the length. So now we have our two let statements. And now that we know that, now I can talk about area. Because to find the area of a rectangle, what do you need? Well, the formula for area of a rectangle is area is equal to length times width. So without having let statements for the width and the length, you wouldn't be able to do this. Now, if you didn't set it up the way I did, and you didn't call x the side that you have two of, it makes this a little more challenging. Now, if you had to fence in on both sides, right, then you would have to divide this by 2 on each side to make it work out evenly. But that's okay. So here we got the area is equal to the length times the width. And then let's actually find that equation. So we have area equals the length, which is 400 minus 2x, times the width. Make sure you put parentheses around this because the whole thing is times the width, which is x. And what I'm going to do is I'm going to distribute into here. Right? So I'm going to distribute the x through. So I get area is equal to, this is 400x, and then minus x times the negative 2x is minus 2x squared. Now what I'm going to do is I'm going to just write this in descending order. So I'm really just rearranging the order of the terms. So I'm going to write this area is equal to negative 2x squared. This is a positive, so plus 400x. Now remember what you're trying to find. Alright, so this is an equation for area. You substitute in an x value, and then the y value you get out would be area, in other words. We can also call this a of x. Area is a function of x. So, looking at this, if I'm trying to find the maximum area, the key thing to notice here is that, well, the x squared here is the highest degree term, right? The highest power we have is 2. We know it's a parabola. The negative in front tells you it's a parabola that opens how? Well, it's a parabola that opens downward. So when does the maximum occur? Well, the maximum occurs at the vertex. So what I'm really asking you to find is the vertex for this. So the x value of the vertex, right, because that's how you find the maximum, is x equals negative b over 2a. Well, what's negative b? It's negative 400. Now when you see this, right, a is the coefficient of the x squared, b is the coefficient of the x, and then c would be your constant. So negative b, make sure you're using the right value. It's negative 400 over 2 times a, which is negative 2. So we've got negative 400 over 2 times negative 2 is negative 4. So negative over negative makes a positive. 400 divided by 4 is 100. And that's 100 what? Well, it's 100 feet. Remember, the width is our dimension. It's measured in feet because the fence is measured in feet. So 100 feet, that's the width. That's what we just found. The width is 100 feet. Well, what's the length then? Well, the length would be 400 minus, 2 times 100. Now, they don't ask you to find that, right? They're asking you to find the maximum area. So, you don't need to find the length, but you could, right? So if I asked you in the problem, find the dimensions and the maximum area, you'd have to tell me the dimensions. Well, the dimensions would be 400 minus 2 times the 100. Remember, we found x is 100, so I'm just substituting into that. So 400 minus 2 times 100 is 200. Well, that's going to be 200 feet. So the width would be 100 feet. The length would be 200 feet. That would maximize the area. But we didn't answer the question, which is what is the maximum area you can enclose? Well, the maximum area, 2 ways you can find it. Probably the easiest way is just to take, the width times the length you just found and say area is equal to, the length times width, which would be 200 times 100, which, if you do it on your calculator, 200 times 100, you get 20,000. So it's 20,000. What's this measured in? Well, it's area. Area is in units squared, so it's feet squared or square feet. So the max area is 20,000 feet squared. Now let's say you didn't do that, and instead of finding the dimensions, so if they ask you for the dimensions, the width is 100 feet, the length is 200 feet, the maximum area is 100 times 200, and you get there. Let's say you didn't find the length, though. Let's say you just said, I got the vertex, I'm going to look for the maximum area. Well, remember, the x value of the vertex, right, was the width. The y value, though, is area. So what I can really do is substitute 100 in and say area is equal to negative 2 times 100 squared plus 400 times 100. I'm just subbing in 100 into this to get the area out. Well, if you were to do this, 100 squared is 10,000 times a negative 2. We'll make this a negative 20,000. Plus, here we got 400 times 100, which would be 40,000. And then this equals negative 20,000 plus 40,000 is going to give us 20,000. And that's still feet squared, or square feet. So it's the same answer. Doesn't change what your answer is. You can either do it by substituting back in or by just finding the area. Now, if the same question was asked, but it said, what are the dimensions that maximize the area? Then they're looking for the width and the length specifically. If they're asking for the maximum area, you need to tell me what the maximum area is. And they might ask you for all three. They might say, what are the dimensions that maximize the area, and what is the maximum area? Then you have to tell me the dimensions and also tell me what the maximum area is. If this problem was set up differently, you might need different let statements. So you have to really draw it to figure it out. If I said only 2 sides needed fence, you could call this x, and this side would just be 400 minus x. If I said that all 4 sides needed fence, you could still call both of these x, and the other ones would be 400 minus 2x, but divided by 2, because half of it would have to go here and half of it would have to go there. So pay attention to how you would set up the let statements here, because you really should be doing it based on what your drawing is. The only other thing I'll point out is that, remember, the vertex gave us a maximum because we had a negative leading coefficient. If you don't have that, then it won't be a maximum, right? So it's important to recognize that because it's a parabola, because the highest power is 2, the first term being negative tells you that it's going to be opening downward, which means the vertex is a max. Let's take a look at the next one. It says the enrollment at a high school can be approximated by the function n of t equals negative 0.043 t squared plus 1.87 t plus 48, where t is the number of years since 1989. So they're telling you what t is, right? So t is years since 1989, and 1 is less than or equal to t is less than or equal to 22. So it's saying between 1 and 22 years, including 1 and 22. It says, in what year will the maximum enrollment occur? All right, round to the nearest whole number. What is the enrollment that year? So in what year is asking us to find t when the maximum occurs, right? So when does the maximum occur? Well, notice this equation is a parabola, right? The highest power is 2. The leading coefficient's negative, so it tells you it opens downwards. So where's the maximum? Well, the maximum is at the vertex. The t value is like your x value. N of t is like the y value. N of t being, you know, the enrollment, the number of students in that year. So we start by saying we want to find the vertex t equals negative b over 2a. Substituting in, negative b is negative 1.87. Remember, that's the middle coefficient. Over 2 times a, 2 times negative 0.043. And this ends up being negative 1.87. So it's negative over 2 times negative 0.043 is going to be a negative 0.086. And if you divide this out, negative over negative we know is going to be a positive. So we have 1.87 divided by 0.086. And we get 21.74. It says to round to what? The maximum nearest whole number. So we'll say this is approximately 22. And it's 22 what? T is time, is the number of years since 1989. So it's 22 years since 1989. Since it's asking you what year, you really want to do 1989 plus 22. You have to actually tell me the year because it says in what year. So 1989 plus 22, we get 2011. So that's the first part of the question. The second part says, what is the enrollment that year? Well, how do you find that? Well, you want to substitute t into n of t because, you know, t is the years, n of t, right, is the enrollment in that year. So we want n of, make sure you substitute in correctly, you want n of 22. We don't want n of 2011, right? So n of 22. So n of 22, we've got negative 0.043 times 22 squared plus 1.87 times 22 plus 48. You should know how to use your calculator here. In this case, I can just substitute in the values as I see them. If your calculator does not display everything on the screen, you would need to type these in using order of operations, finding each piece and then multiplying through and adding. So we got negative 0.043 times 22 squared plus 1.87 times 22 plus 48. And I get 68.328, and it says, right, we're rounding to the nearest whole number. So this is going to be 68 students. So the maximum enrollment for that high school will be in 2011 with 68 students. So it's a small school. But another example where, you know, because it's a parabola, you can find the maximum. If this wasn't a negative in front, if it was a positive, remember, you'd be finding a minimum. And there are questions we'll ask you about a minimum, but you do it the same way. You find the vertex and go through it. Let's take a look at the last one here. This is similar to the problem above about the fence and the river. It says, for the rectangle on the right, determine the value of x that gives the maximum area, and then find the maximum area. Well, to find the maximum area, first thing we should do is find the formula for area. Remember, area of a rectangle is equal to length times width. In our formula, they've already given us what the sides are, so I don't have to actually, you know, write let statements or anything like that. So really, I can just do area is equal to, you know, x plus 4 times 31 minus x. And now what should I do here? Well, at this point, you want to FOIL, right? You want to distribute through and expand this and simplify. So x times 31 would be 31x. X times a negative x is negative x squared. 4 times 31, if we do it quickly, 4 times 31, we get 124, so this is positive 124, and then 4 times negative x is negative 4x. And what I'm going to do here is combine my terms and write it in descending order. So negative x squared is my leading term, right? It's got the highest power. So by writing in descending order, highest power to lowest. We have 31x minus 4x, so this will be plus 27x. And then we got 124 here, so it's positive 124, so we're adding plus 124 at the end. And what you should notice is that your formula for area here, highest power is 2, so we know it's a parabola. The negative in front tells you it opens downward. If it opens downward, then where's the maximum? The maximum is at the vertex. right? If it said find the minimum, then this parabola would have to open upward, right? And you would still find the vertex, but the way it opens matters. So here we got x equals, right, to find the vertex, I need that x value. So x equals negative b over 2a. So what's b? b is 27. So it's negative 27 over 2 times what's a? Well, a is negative 1. Make sure you know there's a 1 in front there and that negative in front of it. So negative 27 over negative 2, because 2 times negative 1 is negative 2. If you divide that, you get 13.5. Now, they didn't tell us what this was measured in, so we'll just say 13.5 units, whatever the units are. Now, that's what x is. Keep in mind that is the value of x that gives the maximum area, but neither of these sides is actually x, right? So 13.5 is just what x has to be to make this rectangle have the maximum area. But that's what it asks us to find. Determine the x value. We did it. But then don't forget, and then find the maximum area. Well, if I'm finding the maximum area, I'm using my area formula, and I'm subbing in 13.5. So we would have area is equal to, now this negative isn't getting squared. This negative is in front. X is getting squared, so it's negative, and then 13.5 is inside parentheses getting squared, and that matters. Don't put the negative inside. It'll change your answer. Plus 27 times 13.5, and then plus 124. And we can evaluate this. You can use your calculator. Make sure you follow order of operations. If you don't have a calculator, it displays it on the screen. So I have negative, and then in parentheses 13.5 squared. Right, so the negative is not getting squared, just 13.5 plus 27 times 13.5 plus 124. And I get 306.25. So this equals 306.25. What are the units? Well, we don't know what the units are, but they're units squared, square units. You know what I'm saying? Because area always has units that are squared. This is the maximum area. Now, something I didn't ask, but if I said what is the length and width, like you would have to substitute x into each of these, and then you would find them. You know, but you don't have to do that unless it asks for it. Right, so I didn't ask for the dimensions. I said find the x value and then find the maximum area. So you found the x value, find the maximum area, you sub into the area formula, and you get the maximum area out. So, you know, hopefully these examples help. You know, typically in these maximum or minimum problems, you'll have a parabola as your equation. You know, if it has a negative in front as the leading coefficient, then it's going to be a maximum because the parabola opens downward. If you have a positive in front as the leading coefficient, that's going to be a minimum because the parabola opens upward. So hopefully these help.